This video answers two homework questions from section 7.5 for Math 98. It's questions 7.5 number 13 and 7.5 number 16. I got a specific version of each from a student, and I'll just talk through these and answer them. As always, remember to send me emails or come to office hours if you have a question. I like answering your question. Okay, so here's 7.5 number 13. It asks us to solve for x in this ridiculous equation. And I say it's ridiculous because it has a million fractions, and I don't want any fractions in my equation. I don't like them. Because I have an equation, I have multiple methods I can use to deal with the fractions. One is to put everything on a common denominator, and the other method is to clear the fractions. That's my favorite method, so I'll go with that. So my plan is I look at the fractions, I want to destroy the fractions. I destroy them by multiplying both sides of the equation. This plan only works because I have an equation. I just multiply by both sides by something big enough to cancel all the fractions. That's called the least common denominator. I don't know what's going to happen after that. After I clear the fractions, I'll have a new question to work on. We'll see what happens after that. So first, I will try to find the least common denominator. Well, I have an x minus 1 and an x plus 3, which are both prime. I'll factor x squared plus 2x minus 3. I'm looking for two numbers that multiply to minus 3 and add to 2. Those numbers are 3 and minus 1. Since my leading coefficient is 1, I get to just write the factors. X plus 3, x minus 1. So I've factored all the denominators, and I see that the denominators are all made entirely of x minus 1s and x plus 3s, and I never have more than one of either. So the least common denominator is just one of each. It's not always just this denominator. It just happened that the denominators are all made of x minus 1s and x plus 3s, and the maximum amount of each is one of each. So I included one of each. So I'll multiply both sides of the equation by this. Now, there's a little bit of a danger in multiplying both sides by something. You can multiply both sides of an equation by whatever you want as long as it's not 0. So I need to kind of like remember that I don't want x to equal 1, and I don't want x to equal minus 3. If x is 1, then this thing I'm multiplying by would all come out to 0. Or if x is minus 3, the thing I'm multiplying by would all come out to 0. So I need to remember at the end not to let any of these into my answer. But if I remember that, I can just multiply both sides by the least common denominator. Because I'm using the tactic of using paper in order to reduce the amount of stuff I have to remember, I started by copying down the entire equation. Then I'll multiply by the least common denominator, which looks like this. Notice that because this is an equation, I could do it to both sides of the equation, and I don't need to multiply the numerator and denominator by the same thing. Instead, I'm multiplying both sides of an equation by the same thing. Okay, the point of this was that it cancels some denominators. X plus 3, x minus 1 equals my whole denominator. So I did it. I executed the plan. The plan was to clear the fractions, and I've done it. Let's see what's left over. What's left over is a new equation. And at this point, I take a deep breath, say, okay, I have a new problem. I can work on this one. And I don't have to remember any of this stuff from before except to rule out certain answers at the end. So what kind of equation is this? It looks like it's going to be a quadratic equation because these x's will get multiplied together. To solve a quadratic equation, I want to get everything over to one side and factor it. So I'll multiply all this out. And I'll multiply this out too, because my plan is to get everything all collected on one side. Let's do it. Add 4x, subtract 4, subtract 8. If I do all that, I'm left with 0 on the right side. On the left side, I get x squared and 1, 2, 3, 4, 5, 6, 7, 8x. And 3 minus 4 is -1, minus 8 is -9. Then I can solve this equation, and I'm solving it by factoring. Look for two numbers who multiply to -9 and add to 8, and that's 9 and -1. Then the zero product property tells me that if these two expressions multiply to equal 0, one of them must be 0. So my final answer is that x is -9 or x is 1. I like to go through these problems with the philosophy that I don't have to remember things from previous steps. I use paper to write everything down so that I don't have to remember stuff from previous steps. But when I zoom out here to like turn in my answer and type in my answer into the computer, I notice that, wait a minute, I did write myself a little note here that said x can't be 1. So at the last possible moment, I can rule out x equals 1. If you didn't make this note to yourself at the beginning, it's okay. You would then have to notice by checking your answer and plugging in x equals 1. And as soon as you look at one part of the question, if you try to plug x equals 1 into this left side, you get 2 over 0, which is a bad sign. 2 over 0 isn't even a number. It can't equal other numbers. So x equals 1 has to get removed from this answer one way or another, and the final answer is actually x equals -9. So that's number 13. To recap it, I looked at the question. It had a lot of fractions. I decided to destroy the fractions by multiplying both sides by the least common denominator. I did it, multiplied both sides by the least common denominator, and ended up with a quadratic. When I solved the quadratic, I got 2 answers, and then I had to notice that one of the answers was actually just not okay, and I crossed it off. I was left with just one answer. Let's look at number 15 next. 16. Let's look at number 16 next. This looks pretty similar, just more of a mess. I'm going to use the same plan. Whenever I see an equation with a bunch of fractions, I try to destroy the fractions. The denominators all look like they factor. The first denominator factors as x times x plus 2. The second denominator factors as x times x plus 1. And the third denominator factors as x plus 1, x plus 2. Combining all this together, I can get the least common denominator, which is the smallest thing that would cancel all the fractions. Well, I need an x, I will need an x plus 1, and I'll need an x plus 2. none of these denominators has any of these factors repeated twice, so I don't need like 2 copies of x plus 1, because none of the denominators have 2 copies of x plus 1. So I will multiply both sides by this least common denominator. At this point, I like to take the moment to remind myself that I can't multiply both sides by 0, so I need to make sure at the end that x is not allowed to be 0, x is not allowed to be minus 1, and x is not allowed to be minus 2 at the end. All of these things would have caused me to divide by 0 in the original question, but this is just a good time when I'm multiplying both sides by something to be like, okay, I don't want to multiply both sides by 0. So let's do it. When I multiply both sides by the least common denominator, it's going to be a huge mess. But I will start by just copying down everything I had before, leaving space for my least common denominator everywhere. Then I will multiply both sides by my least common denominator. The point of this is that it's supposed to make the fractions reduce. Now, often students will look at this and just start multiplying stuff. But that's not the point of this. The point of this was to cancel the fractions. That was our goal. This is why it's important to have a goal in mind, like a tactic when you're doing things. So I'm here because I wanted to cancel the fractions. X squared plus 2x cancels with an x and an x plus 2. X squared plus x cancels with an x and an x plus 1. And the third denominator cancels with an x plus 1 and an x plus 2. When this is all done, I'm not expecting that everything will be finished, but I am expecting that there won't be any fractions anymore. We did it. There's no more fractions. So now I just have a regular old equation, not a rational equation with x's in the denominator. So I take a deep breath, and I put the rest of this stuff out of my mind for now because I don't have to worry about it anymore, except at the end when some of my answers might get thrown out. But I kind of think of this internally as like a new question. I don't have to keep all the rest of that stuff I did in my head anymore. I can just keep this part. It looks like this is going to come out to be a quadratic. Or maybe not, because there's more quadratic stuff here. I'm going to multiply these out and see if this is a quadratic or not. If it's a quadratic, I'll get everything on one side. If it's a linear equation, then I'll get all the x's on one side and all the numbers on the other. So let's multiply it out and see. A dangerous thing here that's good to watch out for is if you're subtracting a product, make sure that you subtract the whole result of the product. I can write that with parentheses here, or I can write that by just making sure that I subtract everything that came out of that product. But messing up this particular minus sign is a very common mistake. Okay, when I simplify all this stuff, it does look like the x squareds actually cancel. So in the end, I have a linear equation. There's no x's squared. It's just x multiplied by numbers. So I'll collect the x's on one side and the numbers on the other. What a mess. Okay, I'll just copy it down again. I guess I'll get all the x's over to the left because I don't like how the x's are all negative over here on the right. So I'll add 19x to both sides. And then to get all the numbers out of here, I'll need to subtract 1 and add 8. Subtract 1 and add 8. These are all out of here. I have 21x minus 6x. That's 15x. And over on the right, I have minus 1 plus 8. That's 7. So my end result is that x is 7/15. I'm a little worried that maybe my answer might not be allowed because I did some crazy stuff, like I multiplied both sides by some variables. So I just checked to make sure that this number is not particularly bad for the equation. And in fact, yeah, the numbers that would cause us trouble would be 0, -1, or -2, so I'm happy with this answer. To recap what happened, I had an equation that had a lot of ugly fractions. I wanted to destroy them, so I did. I destroyed them by multiplying both sides by a least common denominator. That canceled all the fractions and gave me a new equation. I couldn't really tell what kind of equation the new one was until I expanded it out, but when I expanded its individual pieces, it turned into a linear equation where all the x squareds were gone. So I collected all the x's on one side and all the numbers on another and solved for x. That is it. Send me follow-up questions or homework questions anytime by coming to office hours or sending me emails or clicking the little send me a question button in the homework system. I will talk to you later.